Greetings, everyone. This is Zach Beckstrom again. Today we're going to be going over Chapter 2-3, looking at some metric units, and we'll be looking at some more unity fractions and that unity fraction method that we hit on the last section. Doing some more of that today. Alright, so let's take a look at the first slide here, metric length units. So it says the basic unit of length in the metric system is the meter. Most of you have heard of meter, I'm sure. It's the metric system is the system that they use in most of the world. Every industrialized country other than the United States uses the metric system at this time. So it's important, plus in the science community it's used quite often, even in the United States. So I included a table here that has the more common prefixes that we use with the metric units, going from giga, which means, if you look over there, it means what, a billion, right? And then a mega is a million, kilo is 1,000, all the way down to the nano there. So you take a look at that. The base unit would just be called, if you're talking about length, it would just be called a meter. So 1,000 meters, we would look at our table, we'd go to kilo, so that would be a kilometer, and so on. So just like the other unity fractions that we had with the U.S. customary system, we can do the same thing with the metric fractions, and in fact with the metric system it's quite easier because everything is in powers of 10, so it makes converting relatively easier. More often than not you can do a lot of these in your head just by bringing your zero out to the right or left depending on whether you're getting smaller or bigger. But let's go ahead and try this. We know that 1 meter is equal to 100 centimeters. We saw that from the previous slide. So we can set up a unity fraction like we did before, either 100 centimeters over 1 meter or 1 meter over 100 centimeters. Both of those are equivalent, and we'll use the one depending on what unit we're trying to cancel and what unit we're trying to solve for. So let's take a look at this first example here. So suppose we want to convert 467 meters into centimeters. Before I even do that, I'm going to think about it. I know that a meter is much larger than a centimeter. So I know that there's 100 centimeters in each meter. So I should have a whole lot of centimeters in 467 meters. So if I get a real small answer, like 3 or 7 or something like that, I would know that I probably went wrong somewhere. So, but going through the problem here, we can set it up. We can just say 467 meters times, now we're going to use the unity fraction that has the meters on the bottom because we're wanting to cancel out the meters and we want to solve in terms of centimeters. So we do that. That multiplies that 467 times 100. So our answer would be 46,700 centimeters. If we were asked to do this without using unity fractions, it's something that's pretty easily done just in your head. If I'm going from meters to centimeters, I know that my lengths are going smaller, so I'm going to have more of them. And I know that a centimeter is 1/100th of a meter, so I can multiply that 467 by 100, which just moves that 0 out 2 places, or the decimal out 2 places, giving it 2 more zeros. So you know, if you're able to do that without the problem, you can do it, but the unity fractions are always great, especially for the ones that you can't simply do. So go ahead and try some problems on page 125 under your turn. So then metric US length conversions. So we need to be able to switch between talking about inches and feet and meters and centimeters. So it's important that we have an approximation of what a centimeter is in terms of inches and what a mile is in terms of kilometers. They're not nice numbers, but we can set those conversions into our unity fractions in order to solve some of these problems. So convert 15 feet to meters. So notice that we have a conversion from feet to centimeters and from centimeters to meters. So we can't go directly from feet to meters, or possibly we could if we had a table that gave us that, but we can also link it through the two conversions, from the feet to centimeters, which we see on page 126, and from the centimeters to the meters, which we see on page 124. So we always start with what they give us. They give us 15 feet. My next unity fraction, we want to have feet on the bottom, so it cancels out. And we know that 1 foot is equal to 30.48 centimeters, so we set that up as our unity fraction. And then my next one is, I don't want centimeters because our final answer needs to be in meters, so my centimeters needs to be on the bottom of my next unity fraction, so it'll cancel out with the top of the first unity fraction. And we know that 1 meter is equal to 100 centimeters. And since we're solving for meters, that's going to go on the top, and since we're canceling the centimeters, that goes on the bottom. And then we multiply the tops together, so that's going to be 15 times 30.48 divided by 100 is going to come out to approximately 4.6 meters. That little squiggly equal sign means an approximation, and when we have our answer is in units, which generally don't repeat or do repeat but go on a long ways, we will round that, and we'll round that just like we would with multiplication or division, with the smallest number of significant digits from our original problem. So our original amount was 15. That's 2 significant digits. You can go back to one of the previous lessons if you forgot how to find that. So our final answer will also be in 2 significant digits. Alright, so try some more practice on page 127. Moving on, just like length, we can convert other metric units such as weight, mass, area, volume, etc. You're going to see quite a few examples with other types of metric to US conversions. So let's look at an example, and the book has quite a few more examples. And I said before trying a problem like this, the problem is convert 2 square yards to square inches. So before doing this, like we did kind of with the last one, we want to kind of visualize it to make sure that our answer is in the realm of possible answers. So we know a square yard, well, that's going to be 1 yard by 1 yard, which is about 3 feet by 3 feet. So you can look at this as possibly the size of the floor of a closet. And there's 2 of those because there's 2 square yards. Now imagine taking square inches, which is approximately the size of a stamp, and covering 2 closet floors. And I say this because it'll give you a good feeling about how many stamps it would take to cover that. And we know that it would take quite a lot, hundreds, possibly thousands. But it would, definitely take more than 50, and it would definitely probably be less than 1,000,000. So if we get a real small answer or a really huge answer, there's a good chance you made a mistake. And so, we should get something probably in the hundreds or thousands. And if we get something there, then but much greater chance that we have the right answer. So a lot of times we can weed out these mistakes and wrong answers by visualizing it at first, and then seeing if our answer makes sense. So let's set up our unity fractions. In this case, we can do 2. So we start with the 2 square yards. Now think about it. A square yard is 3 feet by 3 feet. So if we're looking at the number of square feet in a square yard, that's going to be 3 times 3, which is 9 square feet. So if you have a conversion table, you can use that, but you can also reason some of these out. So 1 square yard is going to be 9 square feet. So we can set that up as a unity fraction, putting the square yards on the bottom of the fraction in order to cancel it out with the original unit. And then we need to cancel out that square feet because our final answer needs to be in square inches. So 1 square foot, think about that, that's 12 inches by 12 inches. So multiplying that out, you get 144. So there's 144 square inches in 1 square foot. Thus, we can set up that unity fraction. And square inches is the unit that we're trying to find. So we want that on the top of our unity fractions. Usually we'll have it at the last unity fraction, but sometimes it'll be in the middle. And I think we have an example later where we'll have that in the middle. But as long as it's on the top somewhere and it doesn't get canceled out, it'll end up in our final solution. So we just multiply the tops together, 2 times 9 times 144, divided by the bottom, and we're going to get 2,592 square inches. Now in the beginning we said it was probably going to be somewhere in the hundreds or thousands, so that definitely makes sense. I could see it being around 2,500 stamps to cover 2 closet floors. So that means that we're in our acceptable bounds there. So try some of those your turn questions on page 131. Go to the next slide here. Let's try another example here. Let's do a compound conversion. This is one that we've already learned. It's one that uses more than one type of unit to describe it, such as speed. Speed uses distance on the top, and it uses time on the bottom. For example, miles per hour, feet per second, meters per minute. We can describe speed in numerous different ways. So the example is convert, and I just spelled convert there wrong, so it should be convert 1,200 feet per second to miles per hour. So it's pretty much going to be very similar to what we've been doing with a few small caveats here. So 1,200 feet per second is the same thing as saying 1,200 feet in our numerator per 1 second in the denominator. Remember, the term after per will go in your denominator. So that's our starting quantity, our starting amount, our starting measure. We want to end up with miles per hour. So we're going to want to end up with miles on the top and hours in the bottom. So at some point, we're going to have a miles in the top of one of our unity fractions, and we're going to have hours in the bottom of one of our unity fractions, and everything else is going to need to be canceled out. So let's try to work through this one. Well, if I know 1,200 feet per 1 second, I can multiply that by my next unity fraction. I know 1 mile is equal to 5,280 feet, and that's in your book there, around page, I think, 130. And we set that up as a unity fraction with the feet on the bottom because we want to cancel that feet out. And because we don't have feet in our final answer. But look at that, we have miles on top now. So we're kind of done. We want to keep that miles because that's in our final unknown solution that we're looking for. So now we're going to need to get rid of what? Well, we're going to need to get hours on the bottom. So how do we do that? Well, now we're working with unity fractions dealing with time. So I know that 60 seconds is equal to 1 minute, and I know I need to get rid of the seconds on the bottom of our original quantity. So I need to have something with seconds on the top, and so those two will cancel out. So that's why I set up the 60 seconds over 1 minute. And then in order to get from minutes to hours, I have the unity fraction of 60 minutes over 1 hour. Now notice when everything cancels out, your feet with your feet, your seconds with your seconds, your minutes with your minutes, I'm just left with miles per hour. And multiply everything on the top by everything on the bottom, and we're approximately 820 miles per hour. And notice I rounded that to 2 significant digits because my original starting amount, 1,200, was 2 significant digits. They talk about temperature here. There are some formulas in order to convert from Fahrenheit to Celsius and Celsius to Fahrenheit. We're not going to look at those formulas. We're going to use the chart on page 134. What we do is we find one of the temperatures using one of those. For example, if we find 100 degrees on Celsius, we go to 100 degrees on the Celsius side, and the one on the Fahrenheit side is the amount in Fahrenheit. So try that one and then try the questions on your turn. And that's it for today. And thank you very much. Have a great rest of the week.